Question 13a. Using the substitution x equals sine squared theta or otherwise, evaluate the definite integral from x equals 0 to x equals half of the square root of x over 1 minus x dx. The substitution x equals sine squared theta is a composite function. That is, x equals sine theta all squared. So the chain rule will need to be applied to differentiate x with respect to theta. So dx d theta is equal to 2 sine theta cos theta. Multiplying both sides of the equation by the differential d theta, we have dx is equal to 2 sine theta cos theta d theta. Next, change the limits of integration in terms of theta. When x equals 0, sine squared theta equals 0, and solving for theta, we have theta equals 0. And when x equals half, sine squared theta equals half. Taking the positive square root of both sides, we have sine theta is equal to 1 over the square root of 2. Taking the inverse sine of both sides, we have theta is equal to pi over 4. Next, express the integrand in terms of theta. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of the square root of sine squared theta over 1 minus sine squared theta times 2 sine theta cos theta d theta. Now 1 minus sine squared theta is equal to cos squared theta using a Pythagorean identity. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of the square root of sine squared theta over cos squared theta times 2 sine theta cos theta d theta. Now we're taking this square root of squares, so the integral becomes the integral from theta equals 0 to theta equals pi over 4 of sine theta over cos theta times 2 sine theta cos theta d theta. Now there will be some cancellation, so this cos theta will cancel with this cos theta here, and the 2 can be taken outside of the integral. So the integral becomes 2 times the integral from theta equals 0 to theta equals pi over 4 of sine squared theta d theta. Now to integrate sine squared theta, we need to express it in terms of the double angle for cos. Now note that cos 2 theta is equal to 1 minus 2 sine squared theta. And making sine squared theta the subject, we have sine squared theta is equal to half times 1 minus cos 2 theta. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of 1 minus cos 2 theta d theta, which equals theta minus half times sine 2 theta from theta equals 0 to theta equals pi over 4. And applying the limits of integration, that equals pi over 4 minus half times sine pi over 2 minus 0, which equals pi over 4 minus half.